This is further maths. We're going to look at exercise 18A, questions 13, 14, 15, 17. Okay, so question 13. We've got a rhombus and we've got the diagonals of a rhombus bisecting each other at right angles. Means it cuts each other in half at right angles. So we know each side length is 5. So, and we want to find the side length of the rhombus. So these are right angles over here in the middle. So we know that if I get one of these triangles, I know that's 5, and let's call that L. Okay? And that's also 5 as well. So using our understanding of our well, we don't need to use trig, we can use Pythagoras. I know that 5 squared plus 5 squared equals L squared. So L equals to square root of 5 squared plus 5 squared. So let's work out our calculator very quickly. See what we get. So delete this, clear all. Square root of 5 squared plus 5 squared. So get a value of 7.07. Okay, so it's 7.07, and the units are centimeters. 7.07 centimeters. Now so we found the length of each side of the rhombus, and they're the same length. Find the magnitude of ABC. Okay, so ABC is talking about this angle here. Now, since it's a rhombus, the angles are all equal. We know that for any quadrilateral, the addition of the angle is 360 degrees. So if we divide by 4, we get 90. So angle ABC equals 90 degrees. And we're done. For question 14, so let's go. A pendulum swings from vertical at angle 15 degrees. Each side of the vertical, on each side of the vertical. If the pendulum is 90 centimeters long, what is the distance x between its highest and lowest points? So what we can see is that we've actually got an isosceles triangle going on here, and we want to find the value of the highest and lowest points. So let's find the length of the pendulum at the lowest point first. I mean the highest point first. So meaning that this is 15 degrees and this is 90 centimeters. We've got a right angle, and we want to find this distance. Okay, so that's my x for the lowest point. Okay, the highest point. Sorry. So when I work out the distance, I've got let's see what ratio we've got. Adjacent hypotenuse. So cos of 15 degrees equals adjacent, which is x over 90. So when I solve that, I get x equals 90 cos 15 degrees. So let's write this again. X equals 90 times cos of 15 degrees. Okay, let's work that on a calculator. 90 cos, make sure we're in degree mode, of 15 degrees. So 86.933. So 86.933 centimeters. Now, at our lowest point, that's a bit different. Okay, at our lowest points, we can see that if the pendulum drops over here, the pendulum would be at this spot. Okay, and what's the distance? The distance doesn't change. The distance, the length of the pendulum doesn't change. So this whole length must be 90. Okay, so the lowest point would be 90. So lowest point would be at 90 centimeters. Okay, this point isn't the last point, only due to the fact that it's been moved up. Okay, if it's moved to its normal position down, like it when it stops swinging, then it's 90. So if I subtract 90 from 86.933, we should get our answer. So we can go 90 subtract, instead of typing that all again, I'll just drag and drop 3.07. So 3.07 is the distance between highest and lowest. Okay, so that's how you approach question 14. Question 15, a picture is hung symmetrically by means of a string passing over the nail. Okay, so we can see that the two sides are equal. So we have a, it says symmetrically, meaning it's a isosceles triangle. Okay, passing over the touch. Okay, the two rings. Find this. Okay, so let's read the question. A twig is attached symmetrically by means of a string passing over a nail with its ends attached to two rings on the edge of the picture. The distance between the rings is 30 centimeters. Find the length of the string. Okay, so the distance between 30 centimeters. So I'm assuming what it's saying is that we've got a scenario where that's 105. The distance between the two portions is 30 centimeters. So I'm assuming the rings are here, 30 centimeters. And we want to find the length of the string. So we want to find x and x, okay? Since this is a isosceles triangle, I can divide this into two right angles, okay? So this will be 15, and this will be 105 divided by 2, which is 52.5, okay? And this will be my x. So adjacent, opposite hypotenuse, sine 52.5 equals 15 divided by x. X would equal, I can use interactive and solve. So sine, remember you can't use interactive and solve if you're solving for angles, but you can do it for sine. So 52.5 equals 15 divided by x. I go interactive and solve, and I get 18.91. Okay, now 18.907, 18.907, 18.907. If I multiply by 2, I get the total amount of string I need. So if I multiply by 2, I get, so if I multiply my answer by 2, I get 37.81. Okay, so 2x equals 37.81 centimeters. So that's the amount of string I need. Now, the third question is, a ladder 4.7 meters long is placed against the wall. Okay, so we've got a wall here, and we've got a ladder which is 4.7 meters long. The foot of the ladder must not be placed in a flower bed which extends 1.7 from how high can the ladder reach? Okay, so the foot of the ladder must, so we got a flower bed somewhere. Let's draw a flower bed. So we've got a flower bed, flowers here, and must not from the foot of the wall. So it cannot go more than 1.7. Okay, if it goes 1.7, we're gonna destroy the flower bed. How high can it reach? So we just want the value of x. That's our theta, and we want the value of x. So in this case, we can basically use Pythagoras because we got two sides. We got that side and that side, and we don't even really need the angle. We know that's a right angle because it makes a right angle for the wall. All we need to do is do a Pythagorean relationship. We're trying to find the shortest side, so x would equal to the hypotenuse side squared minus the short side squared. So x would equal, how high can the ladder reach? So let's work this out. So square root of 4.7 squared minus 1.7 squared, 4.38. Okay, so it's 4.38. 4.38 meters. And we are done. Okay, so the trick in this question was to actually interpret like what it's actually telling me.